Hi friends, welcome back to new session. In the last session, we started Lenz law topic. So I think we completed Lenz law topic also. And let me proceed with the last session. Let me explain the self-induced EMF, self-inductance, mutual induced EMF, and mutual inductance in this session. Okay. So what is the conclusion? What was the conclusion in the previous session, guys? So after considering Lenz law, in primary side you should write V1 bar equals to minus C1. In the secondary side you should write E2 bar equals to V2. Okay, see here for applied voltage source V1 it is a plus minus, and for this E1 it is a plus, here it's a minus. So since Ix opposing I mu, I can indicate V1 bar equals to minus C1 bar here. And if you see in secondary side, so I think I already wrote, okay, this for this E2 is a plus and here it is minus. For load voltage is a plus minus E2 and here V2. Because of E2 we'll get current Iy. We don't have any current because of load voltage V2. There is no opposition. Simply we can write E2 bar equals to V2 bar. This was the conclusion, right? Now guys, let me give definition for self-inductance, self-induced EMF, mutual inductance, mutual induced EMF in this session. Okay. So first of all, before that, tell me what is the EMF induced in a transformer? Statically induced EMF. So EMF induced in transformer can be called as statically induced EMF. That everybody knows that. And direction of static EMF is given by Lenz law. About that Lenz law only we discussed here. In coming videos also, regarding waveform point of view also I explain Lenz law. That will be somewhat easy for you when compared to this portion. Because here what was the conclusion? Angle between V1 and E1 is 180 degrees. That 180 degrees only, this minus symbol indicating. This minus symbol is because of what? Minus symbol is because of Lenz law. If you are very comfortable with this discussion, this is okay. Suppose if you are not able to understand, sir, how we got V1 bar equals minus C1 bar, I am not able to understand this in this, by using this topic, by using this discussion, I am not able to follow like that. If people are thinking, no problem. In the next video, videos, I will be discussing Lenz law only where angle between V1 and E1 I will be showing 180 degrees. There I will be using waveforms. By using waveforms also I can show angle between V1 and E1 is 180 degrees. Like that we'll conclude some angles, okay, between some vectors. Okay. Anyway, I think it is very good for you. This will be, you should know this one. This portion you should know. Please try to watch a previous video clearly, slowly, one time, two times, three times, like that, so you can understand subject easily, no problem. Okay, nice. Now, what is the conclusion? In transformer, static EMF will be induced. In statically induced EMF, once again, if you see transformer, statically induced EMF is classified into two types. Number one, self-induced EMF, or I can say, primary EMF. That can be shown with E1. So self-induced EMF or primary EMF that can be shown with the E1 or Eself. Similarly, mutual induced EMF or secondary EMF, let me show with the E2. Okay, E2. See guys, first of all, in the last video I told, once again repeating, whenever time variant voltage source is connected to the transformer, so current taken by the transformer I mu is also time variant or AC. So because of I mu, you will get flux in transformer core is time variant or AC. Okay. Next, because of this pi, you will get EMF in primary winding E1 proportional to what? Rate of change of flux linkage. What are the number of turns in the primary side? N1. So flux pi. Is it clear? And once again, because of this pi only, we will get EMF secondary winding also, no? E2 proportional to rate of change of flux linkage in secondary winding, nothing but N2 into pi. So guys, please try to understand clearly here. So let me discuss self-induced EMF first. Self-induced EMF. What is the definition for self-induced EMF? Indirectly I am asking what is the definition for primary winding EMF I am asking. Okay, simple. EMF induced in the primary winding because of time varying current flowing in the primary winding itself. See, E1 is because of this pi. This pi is because of what? This I mu. This I mu is flowing in the primary winding itself. So what is the definition for self-induced EMF? Okay, you please write self-induced EMF or primary winding EMF in bracket E1 and write definition. Self-induced EMF or primary winding EMF in bracket E1, you just write definition. EMF induced in the primary winding, EMF induced in the primary winding, EMF induced in the primary winding because of time varying current, because of time varying current, because of time varying current flowing in the primary winding itself, because of time varying current flowing in the primary winding itself, okay. So please guys, tell me, I already wrote here Eself or even both are same only. So let me write here Eself is equals to, you said Eself is equals to what you said, N1, if I take N1 outside, d pi by dt. This is the definition for Eself. Please try to see here. E1 or Eself both are same only, d by dt of N1 into pi is said. So I am writing Eself equals to, I had taken N1 outside, d pi by dt. And please try to see guys, Lenz law what it says, according to Lenz law, induced current develops a flux which always opposes the change responsible for inducing this current. If you see, very simple here also, this EMF E1 is because of which flux, this flux. So I can take this flux as pi as cos. Now in this case, in this discussion, I can take this pi as cos, I can take this E1 as effect. So simply Lenz law what it says, effect opposes cos. So who is responsible for having this EMF E1? Pi. So that means E1 should oppose this pi. Yes or no? For opposition, for indicating that E1 is opposing pi, I am writing here minus symbol. This minus symbol indicates what? It is because of Lenz law. To show that opposition only, we are indicating that minus symbol. Okay. So effect opposes cos. So I can write here. That's why I am just showing here minus symbol. This minus symbol is due to what? Due to Lenz law. Due to Lenz law. Due to Lenz law. See, already I had given. Just go through that. You will be having some clarity. See, in this discussion, I had taken V1 as cos. I had taken E1 as effect. Generally, V1 equals E1 is the equation we will get. But because of V1 we are getting I mu in previous video. Because of E1 we are getting Ix. This Ix opposing I mu. To show that opposition only, we are showing this minus symbol. In this discussion, V1 is cos, E1 is effect. And in this discussion, pi is cos, E1 is effect. Yes, I can show minus symbol. It's due to Lenz law only. Okay, right. Next guys. So now tell me Eself, or I can say E1, nothing but primary winding. Eself is equals to minus N1 d pi by dt multiply numerator and denominator with di. Okay, di. Now please write, see, please try to see here. This di by dt you should write separately. Yes, di by dt I am just writing here. Next, whatever remaining is there, minus n1 d pi by di. So please take this n1 inside, minus d by di of n1 into pi into di by dt. This is a formula for self-induced EMF. Okay, and you know, generally we know, everybody knows that voltage across the inductor is nothing but L di by dt. Like that, if you compare this equation with the minus, I am just writing like this, minus Lself, self-inductance into di by dt. Just compare these two equations guys. but Eself and here Eself. Okay, so let me compare this expression with this expression. So let me take 1 and this one as a 2. From 1 and 2 guys, from 1 and 2, what is the conclusion for Lself? I am asking formula for self inductance. Lself is equals to what? D by di of n1 into pi. So please note down this and let me give definition for self inductance also. You please try to note down this one. After writing this one, you just write definition for self inductance, please. Just write as a note. Okay, I think I had given already definition for self induced EMF. Like that, let me give definition for self inductance. Okay, note down. Self inductance Lself is defined as rate of change of flux linkage. See, rate of change of flux linkage. See, I just wrote here N1. N1 means what? It indicates primary winding. So Lself is defined as rate of change of flux linkage in the primary winding. Lself is defined as rate of change of flux linkage in the primary winding due to see denominator, please try to see here it is di is there, no? Due to time varying current flowing in the primary winding itself. Is it clear? That is definition for self inductance. Okay. Now here see guys, one previous question was asked here. You should be very careful here. See, here Eself is equals to minus n1 d by dt, whatever I just wrote here. Okay, so this is nothing but what? It is a summarization of Faraday's law and Lenz law. This was the previous gate question, so very important. It was the previous gate question. That means see, if you write Eself equals to minus n1 d by dt, that equation actually represents what? That is the question. See here already d by dt of n1 into pi is d by dt of n1 into pi, means rate of change of flux linkage should be there for getting a EMF in a conductor. That actually that is the statement because of Faraday's law. And since I kept here minus symbol, this minus symbol is because of Lenz law. That means if I write this equation Eself equals to minus n1 d pi by dt, it is a summarization of Faraday's law and Lenz law. Okay, very important. Please remember. Sometimes they may they may ask like this also. Generally this equation Eself you are writing like this, no? Eself equals to minus d by dt of, if I take n1 inside, n1 into pi. So this is nothing but summarization of Lenz law and Faraday's law. N pi means what? N pi means what? Flux linkage that generally represented with a psi symbol. What is that? Psi symbol. So suppose if they give you in options Eself equals to minus d psi by dt, that is also same statement. Okay, don't confuse. In place of n pi, they might have give psi. Psi means what? N pi. That should be very careful. Okay. So Eself equals to minus n1 d by dt, summation of Faraday's and Lenz law. Eself equals to minus d by dt of n1 into pi, summation of Faraday's and Lenz law. Eself equals to minus d psi by dt, summation of Faraday's law and Lenz law. Is it clear? So very important, please remember that. Okay. Now, after completion of Eself and Lself, please try to keep hitting Emutual, please. Emutual. I am just going to modify here only. It will be easy for you. Okay. See guys, E2 or Emutual means d by dt of n2 into pi. No, let me write here Emutual. I am just giving definition for Emutual. Tell me. E mutual is equals to what? Minus, okay, d by dt minus, I am taking n2 outside, minus n2 d pi by dt. Once again, it's a summarization of Faraday's and Lenz law. So please, in place of Eself, write E mutual minus d by dt. I taken n2 inside, n2 into pi. n2 into pi means flux linkage, nothing but psi. So E mutual is equals to minus d psi by dt. And please let me modify here also. E mutual is equals to what? Minus n2 d pi by dt into di by di, minus n2 d pi by di by dt. I am writing here. Next, E mutual is equals to minus d by di of n2 into pi into di by dt. Very simple. Wherever self is there, I am writing mutual only here. Okay, and here E mutual is equals to minus m. I am writing m means what? Mutual inductance di by dt. From 1 and 2, mutual inductance m is what? Mutual inductance m is nothing but what? M is equals to d by d of n2 into pi. N2 into pi. So please, first of all, let me give definition for E mutual. Then just write down all those things, and after writing m, let me give definition for mutual inductance m also. Okay. First write definition for E mutual. I am just giving definition for E mutual. See, E mutual nothing but E2 only, means EMF induced in a secondary winding, okay, due to time varying current flowing in a primary winding, whereas primary winding and secondary winding are magnetically coupled with each other. If you want, you can see here. See, it is because of this pi. This pi is because of this I mu. This I mu is flowing in a primary winding. That's it. Okay. Note down. Let me give definition for E mutual. Yeah. E mutual definition. EMF induced in secondary winding. EMF induced in a secondary winding. EMF induced in secondary winding due to time varying current flowing in a primary winding, due to time varying current flowing in a primary winding, due to time varying current flowing in a primary winding, comma, where primary winding and secondary winding are, magnetically coupled with each other, where primary winding and secondary winding are magnetically coupled with each other. Okay. Next, note down all those things. Next, let me give definition for mutual inductance M. Please, right? Mutual inductance M. Mutual inductance M is defined as rate of change of flux linkage in secondary winding. Rate of change of flux linkage in secondary winding. Please try to see in this M equation, N2 into pi is there. N2 means what? Number of turns in secondary winding. That means N2 pi means what? Flux linkage in the secondary winding. So mutual inductance M is defined as rate of change of flux linkage in secondary winding due to time varying current flowing in primary winding, due to time varying current flowing in primary winding, comma, where primary winding and secondary winding are magnetically coupled with each other. Is it clear? See guys, this is a thing. In the last video I discussed Lenz law. In this video I discussed self-induced EMF or primary winding EMF represented with Eself or E1. I explained self-inductance. I explained mutual induced EMF or secondary EMF can be represented with E mutual or E2, and we explained mutual inductance M also. Is it clear? See, in the next video we are going to see what is the angle between V1 and I mu, And what is the angle between I mu and pi? What is the angle between E1 and pi? What is the angle between E2 and pi? What is the angle between E1 and E2? What is the angle between V1 and E1? What is the angle between V1 and E2? What is the angle between V1 and IW? IW is one particular current. It is very simple. IW is used to represent core losses in transformer. Anyway, that we will be discussing. Angle between V1 and IW, and among I mu and IW, which one is very large? Okay, so all those things I will be explaining, and after discussing all those things, all those angles, okay. So I'll have one we'll be having one waveform. From that waveform, we'll be getting angles between particular vectors. After getting those angles between particular vectors, we'll start drawing a vector diagram for transformer under no load, under load condition also. Similarly, we'll go for equivalent circuit of transformer under no load and under load condition also. Okay, thank you.